This is Ben McGahee with Yamie Chess. I'm going to be your math teacher today. Yamie Chess is the math learning aid based on classic chess that helps students in math and science education for school. In this lesson, we will learn about the Pythagorean Theorem, or right triangles. Pythagorean Theorem was discovered by an ancient Greek mathematician named Pythagoras. And he discovered a very important relationship between the legs of the right triangle, and these right here are the legs, and the hypotenuse, the longest side of the right triangle that's opposite of the right angle of 90 degrees. So he discovered that the sum of the squares of the legs, a squared plus b squared, is equal to the square of the hypotenuse, c squared. So a squared plus b squared equals c squared. The Pythagorean theorem has a lot of history, and there have been many mathematicians, professional and amateur mathematicians, who provided proofs on the Pythagorean theorem. I think there are over 250 different ways to prove Pythagorean theorem. We're not going to look at proof of the Pythagorean theorem in this lesson, but we're going to learn how to use the Pythagorean theorem to find the missing side of a right triangle given two known sides. So let's look at a couple examples. So let's say we have a right triangle we're going to draw. And we got a right angle. So a right triangle always has a right angle, and then the hypotenuse is always longest side across from the right angle. And let's say we have this leg, we're going to have be 3 inches. And let's say this leg here, 4 inches. And then let's say we want to find the hypotenuse. We'll call that C. So we have two known sides, 3 and 4 for the inches. And then C is the unknown side, the hypotenuse that we want to try to find. So we know that our equation for Pythagorean theorem is a squared plus b squared equals c squared. And so A and B represent the legs of the right triangle, and C represents the hypotenuse. So we'll call the A is 3, B equals 4, and then we're trying to figure out C. So we do not know the value C. So putting this into our formula, we have A is 3 squared plus B 4 squared equals C squared. So that's the hypotenuse that we're trying to find. And so it's 3 squared, that's 3 times 3, it's 9, plus 4 squared, 4 times 4, 16, equals C squared. And then 9 plus 16 is 25, which equals C squared. And to figure out C, we need to take the square root of 25. Okay, and so the square root of 25 is what number times itself is 25. So we have 5 times 5. We know it's 25, so it must be 5. So C equals 5 inches. That's our units. 5 inches for the hypotenuse. So this is what we call a 3, 4, 5 right triangle. Okay, so now let's look at another example. Right triangle. Okay, so we're going to be given an hypotenuse. So we'll do this 10 and give one of the legs. We'll say that this is 6, and we want to figure out the other side. And we'll just call that B. So we know a leg and we know the hypotenuse. So the leg here is 6. So we'll say A equals 6. And then hypotenuse C equals 10. And the B is our unknown side that we're trying to find. So again, we're going to use the Pythagorean Theorem, a squared plus b squared equals c squared. And so we know that a is 6, so we have a squared, 6 squared plus b squared, we don't know b, equals c squared. So that's 10 squared. And so 6 squared is 6 times 6, that's 36, plus b squared equals 10 squared, that's 10 times 10, that's 100. Okay, so we need to isolate the b squared, get that by itself. So what we can do is we'll do subtract 36 to both sides, doing the opposite of adding, subtracting. So those are going to cancel. And then 100 minus 36. Let's borrow. So that 10 becomes 9. That's 10. So 10 minus 6 is 4. And then 9 minus 6. Or excuse me, 9 minus 3 is 6. Got my numbers mixed up there. It's 64. So we have b squared equals 64. And then to solve for b, we're going to take the square root of 64 and think of what number times itself is 64. So we got our times table, so you know what's that, 8 times 8 is 64. That's perfect square, so we know b equals 8. So we know that b is 8. Okay, so those were a couple examples to illustrate, describe the Pythagorean theorem, and now you are going to try some problems on your own. So you try. So the first problem asks us to find the missing side of this right triangle. We have a leg's 5 units, another leg of x units, which we don't know. That's what we're trying to find x. And then we also have hypotenuse of 13 units. So you need to find out what is x. And then for the second problem, determine if a triangle with sides 11 feet, 14 feet, and 18 feet is a right triangle. So you're going to need to use the Pythagorean theorem to determine if that's true. A squared plus b squared equals c squared, and see if that equation is true for those 3 sides of the triangle. Does it form a right triangle? And I will give you some time to figure those out. Feel free to pause the video or rewind the video to review Pythagorean theorem, and then we'll go over the answers. Okay, so let's go over the answers. So find the missing side, which is x. So we have x here. And we have 5 and 13. So we use the Pythagorean Theorem. A squared plus b squared equals c squared. So we'll have 5 squared plus our unknown side is x squared equals 13 squared. So 5 squared is 5 times 5 is 25 plus x squared equals 13 squared is 13 times 13. It's a kind of bigger number. So let's see, 3 times 3 is 9. 1 times 3 is 3. 1 times 3 is 3. 1 times 1 is 1. Add those together. Got 9. 3 plus 3 is 6. And bring down the 1. 169. And then we have to subtract the 25 to both sides because we're adding. So do the opposite. Subtract. And so this will give us x squared equals 169 minus 25. So that's 4. Let's see, 1. 9 minus 5 is 4. 6 minus 2 is 4. And then we bring down the 1, so that's 144. And then we square root 144. Find the square root to find x. And so with 144, you know that 12 times 12 with times tables 144. So x has to be 12 units. X equals 12. And then for the second problem, determine if triangle with sides 11 feet, 14 feet, and 18 feet is a right triangle. So a way to do that is just put 11 in for A, 14 in for B, and then 18 goes in for C, and see if that's true. So we'll have 11 squared plus 14 squared equals 18 squared. So we want to see if this is true. So 11 squared is 11 times 11. That's 121 plus 14 squared. 14 times 14. So that's 4 times 4 is 16. Here 4. 4, 5. 1 times 4 is 4. 1 times 1 is 1. And you add those. So we bring down to 6. 9, 1. So that's 196 equals, and then 18 squared, we're going to do 18 times 18. So it would be 8 times 8, 64, carry 6, times 8 is 8, plus 6 is 14. And then bring 1 times 8 is 8, 1, down there 0, that's 4, add 4 plus 8 is 12. 1, 1's 2, 2, 1's 3, so that's 324. So we want to know if 121 plus 96 is at 324. So we'll add that to the side here. 1 plus 6 is 7, 2, 9 is 11, carry the 1, 1, 1's 2, 2, 1's 3, 317. But 317 does not equal, right? Does not equal 324. So that equal sign with slash through means does not equal. So since we know that, we can say it's it would be no, right? It'd be no for a right triangle. So not a right triangle. So let's check our answers here and see if we have, oops, I clicked the wrong thing here. Yes, we have x equals 12, and no, it's not a right triangle. So that's right. So if you got those, excellent job. This is Ben McGahee, and I want to thank you for watching this lesson on the Pythagorean Theorem. It's a squared plus b squared equals c squared for a right triangle. Right triangles only. And please stay tuned for more lessons on YamieChess.com. Have a great day.